Myself Aher from RBNB College, Rampur. Today, I deliver a lecture on rotational dynamics, topic of 12th science for NEET, JEE and CET. We know that there are two types of circular motion, uniform circular motion and non-uniform circular motion. Today, we study about non-uniform circular motion. In case of non-uniform circular motion, linear speed is variable, means the motion of an object along the circumference of a circle with variable linear speed, that is called as non-uniform circular motion. So, for non-uniform circular motion, we consider here vertical circular motion. Now, in case of vertical circular motion, velocity or linear speed continuously goes on changing, and that's why it is called as non-uniform circular motion. So, here we consider 4 points. Point A, point B, point C and point D. If object is moving in anti-clockwise sense, as like this one, then linear speed or velocity at point A is given by VA. Linear speed at point C is given by VC. Linear speed at point B is given by VB. And linear speed at point D is, say, VD. Velocity at point C and velocity at point D both are same. But velocity at point A, it is very small. Its magnitude is very small. Its magnitude goes on increasing when it moving from A to B. And again it goes on decreasing from B to A. So at point A, velocity is under root RG, where R is a radius of the circle, G is acceleration due to gravity. Remember this velocity. It is under root 1 RG. Now velocity at point C is given by under root 3 RG, where R is again radius and G is acceleration due to gravity. And velocity at point B, it is a maximum, that is equal to under root 5 RG. Remember these values of velocity at point A, B and C. Velocity at A is very small. Velocity at B is very large. And velocity at point C and D is midway between VA and VB. So, velocity at C and D both are same, that is equal to under root 3 RG. So, remember these values of velocities at point A, at point B and at point C and D. Means velocity of object at point A, upper position, which is very small, VA is equal to under root 1 RG. Velocity at lower position at B is under root 5 RG. And velocity at point C and D both are same, that are equal to under root 3 RG. Remember all these values. Velocity at point A, velocity at point B and velocity at point C and D. Now, we have to study about next point. Moment of inertia. For moment of inertia, we know that a body rotating about its own axis, that motion is called as rotational motion. And for that purpose, we consider a rigid body as like this one. And this rigid body rotating about an axis passing through its center O. And this axis is perpendicular to plane of that figure. If we consider this body consists of n particle of masses say m1, m2, m3, dash mn, which are situated at distances say r1, r2, r3, dash rn respectively from the axis of rotation. Then its moment of inertia I is equal to summation I tends to 1 to n mi ri square, where mi is the mass of each particle, ri is its distance from axis of rotation. So from this formula we get moment of inertia of a rigid body rotating about an axis is equal to sum of product of mass of each particle and square of its distance from axis of rotation. Here we consider rigid body and its moment of inertia is given by I is equal to I equal to summation I tends to 1 to n mi ri square. If there is a uniform distribution of mass, then same formula will become I is equal to integration r squared dm, where dm is mass of each element and then moment of inertia will become integration r squared dm. Now we consider different bodies. If we consider thin uniform rod of length capital L and mass capital M rotating about an axis passing through its center C in this direction, then its moment of inertia I is equal to m r square upon 12. Its moment of inertia is m r square. Here we consider length and therefore instead of r we take here length L square and total length of rod is L. So moment of inertia of a rod rotating about an axis passing through the point C, that is equal to ml square by 12. Now if we consider same rod which is rotating about an axis passing through its one end as like this one. If this rod is rotating about this axis, now distance between C and point A is L by 2. If total distance is capital L, then this distance AC will become L by 2. By applying principle of parallel axis, we find out its moment of inertia. IO is equal to IC plus M R square. Now in that case, this distance is equal to L by 2. So we substitute here R is equal to L by 2. Then we get IO, means moment of inertia of a rod rotating about an axis passing through its one end, that is equal to m L square by 12 plus m L square by 4, and that is equal to, finally this is equal to, on solving we get m L square by 3. So here we consider thin uniform rod rotating about an axis passing through its one end. Now if we consider another rigid body, if we consider ring, thin uniform ring rotating about an axis passing through its center. So this is the thin uniform ring rotating about an axis passing through its center, say O. This ring having a radius capital R. Then for its moment of inertia is mr square. Its moment of inertia is mr square. Here we consider thin uniform ring. This ring is rotating about an axis in any sense, clockwise sense or anti-clockwise sense. Then its moment of inertia is mr square. Now when we consider same ring, place one above other, then there is formation of hollow cylinder, and that hollow cylinder having radius, same radius that of the ring, and that radius is capital R. Now if this hollow cylinder rotating about an axis passing through its center as like this one, then its moment of inertia same that of the ring. So this moment of inertia is also equal to mr square. If this hollow cylinder rotating as like this one, then moment of inertia is same. So remember here, for ring and for hollow cylinder, its moment of inertia is same. Here we take a ring and one above the other ring, then there is formation of hollow cylinder, and therefore its moment of inertia is same. Now if we consider same hollow sphere, hollow ring, in that case its radius goes on decreasing, then there is formation of hollow sphere. There is formation of hollow sphere, and if this hollow sphere is rotating about this axis, now if you consider central thin uniform ring as like this one, this ring having radius say capital R, then its a moment of inertia about this axis, that is equal to I equal to 2 by 3 mr square. So its moment of inertia is 2 by 3 mr square. Here we consider hollow sphere. Now at the center, ring having radius capital R. When we go in upward direction, radius continuously goes on in decreasing. In downward direction also radius goes on decreasing. So here we consider thin ring of different radius. And in case of hollow cylinder, we consider thin rings of same radius. In that case, radius remains same, and in that case, radius goes on decreasing. Central radius is a maximum. And that's why its moment of inertia is 2 by 3 mr square. Now instead of this ring, if we use solid disk. Here we consider disk, and if this disk is rotating about its axis, passing through its center, as like this one, and this disk having radius say capital R. So if this disk is rotating about an axis passing through point O, this axis is perpendicular to the plane of the disk, then its moment of inertia is given by mr square by 2. So this moment of inertia is mr square by 2. This is disk, thin uniform disk rotating about an axis passing through its center. Remember all these formulas. Now for solid cylinder, we consider same disk one above the other, then there is formation of solid cylinder as like this one, and this disk having radius capital R. So here we use same disk of radius capital R, and this solid cylinder is rotating about an axis as like this one. Then its a moment of inertia I is equal to, if this disk is rotating about this axis in this manner, then its moment of inertia is same, that is equal to mr square by 2. So here we know that as like ring, both having same moment of inertia. As like ring, here also same moment of inertia for solid disk and solid ring, solid cylinder. Solid disk and solid cylinder having same moment of inertia, that is equal to mr square by 2. For formation of solid cylinder, we use same solid disk of same radius, and therefore its moment of inertia for solid cylinder is mr square by 2. Now if we use same disk at the center and its radius continuously goes on decreasing, then there is formation of solid sphere. There is formation of solid sphere as like this one. This solid cylinder, at the center there are these solid disk having radius say capital R. Again radius continuously goes on decreasing on above side and also on below side, radius continuously goes decreasing, and if this solid sphere is rotating about this axis in this manner, solid sphere, then its moment of inertia I is 2 by 5 mr square. Its moment of inertia is 2 by 5 mr square. Now see here, for our convenience, we multiply all these mr square by 2. So here we write I is equal to 2 mr square by 2. Then we get answer, same answer, mr square. 2 get cancel and then we get mr square. So moment of inertia of a thin uniform ring and hollow cylinder, that is equal to mr square. Now if we consider this hollow sphere, then its moment of inertia for hollow sphere is 2 by 3 mr square. Here 2 mr square is common, so we write 2 mr square upon 3. Again here we can write in similar manner this moment of inertia I is equal to 2 mr square upon 4. If we simplify this, then we get same answer, I is equal to mr square by 2. And finally here is 2, so we write here moment of inertia is 2 by 5 mr square. So for our convenience we write 2 mr square by 2, 2 mr square by 3, 2 mr square by 4, and finally we get 2 by 5 mr square. So when we observe all these moment of inertia, then this moment of inertia of a solid sphere is very less. It is equal to 2 by 5 mr square. So remember all these values of moment of inertia for ring, hollow cylinder, hollow sphere, solid disc, solid cylinder and solid sphere. For remembering it, we multiply by 2 upward side. So here we write 2 mr square, 2 mr square, 2 mr square, 2 mr square common. Now for below side here is 2 for both this one. For this single one 3, for this single double one 4, and finally we get 5. So we increase this digit by increasing 1, 2, 3, 4 and 5. But upward side is common, 2 mr square, 2 mr square, 2 mr square and 2 mr square. So in this way we remember this moment of inertia for a ring, hollow cylinder, hollow sphere, hollow solid disc, solid cylinder and solid sphere.